All right, today we're going to take a journey into the world of a pathologist. We're going to see how they basically become detectives, solving the mystery of thyroid cancer by piecing together clues, one tiny cell at a time. So let's start the investigation. It almost always starts with something simple. Someone finds a painless little lump in their neck, a solitary thyroid nodule. And that discovery immediately kicks off the big question that drives this whole entire process. What is this, and what do we do next?
So once a tissue sample makes it to the lab, the real work begins. But you might be surprised to learn that before any fancy, high-powered microscopes even get turned on, the very first step is just looking at it. Simply seeing what the sample looks like to the naked eye.
Now, this whole process has a name. It's called the gross examination. It's the pathologist's first look at the evidence on a large scale, the macroscopic view. Think of it like a detective doing the first sweep of a crime scene. They're looking for the big, obvious clues before they start dusting for fingerprints. So what kinds of clues are they looking for? Well, a few things really stand out. First, are the edges fuzzy and ill-defined? That could suggest it's invading the tissue around it. Second, is it a solid, hard mass? That's a pretty common sign of cancerous growth. And third, if it's a cyst, are there these little finger-like growths inside? Every single one of these is a vital piece of the puzzle. These initial clues, they're absolutely crucial, but they're not enough to solve the case. To really get the full story, to truly identify our culprit, we've got to zoom in, way in. We have to go deeper, down to the cellular level. And here they are. This is where we meet our four main suspects in the world of thyroid cancer: papillary, follicular, medullary, and anaplastic. Each one has its own MO, its own typical victim profile, and most importantly, a unique microscopic clue. It's like a cellular fingerprint that helps the pathologist make a positive ID.
Okay, first up is suspect number 1, papillary carcinoma. This is, by a long shot, the most common type we see, and its identity is almost always given away by some really specific, kind of weird features you find inside the nucleus of the cell.
So why the name papillary? Well, under the microscope, this cancer is famous for these intricate branch-like structures. They're called papillary fronds. And each one of these little branches is supported by a core of tissue and blood vessels, which is basically the lifeline that feeds the tumor. But the real smoking gun for papillary carcinoma is the cell's nucleus. Pathologists call it a ground glass appearance. And it's because the genetic material inside is so spread out and fine, a sure sign of chaotic, uncontrolled activity, that the nucleus just looks empty, clear. It is an unmistakable clue. And here's another classic feature you might spot: seismoma bodies. The name actually comes from the Greek word psamos, which means sand. And honestly, it is the perfect description. They're these tiny, layered little balls of calcium, like microscopic grains of sand scattered throughout the tissue. All right, let's move on to our second suspect, follicular carcinoma. And this is where the investigation gets really challenging. Because under a microscope, this thing can look almost identical to a totally benign tumor. The line between harmless and malignant is incredibly, incredibly fine.
I mean, this slide just lays out the challenge perfectly. On the left, you've got a benign tumor, all nice and neat, contained in its little capsule. On the right, you have the cancer. See, it looks almost the same. The only difference, the one single thing that defines it as cancer, is finding proof that it's invading, that the cells have broken out of that capsule or gotten into a blood vessel.
Okay, on to suspect number 3, medullary carcinoma. This one is different right from the start. It doesn't come from the main thyroid cells. It grows from these specialized C cells, which are actually neuroendocrine cells. And because it has a totally different origin, it leaves behind a completely unique set of clues. So when you look close at the cells, the chromatin, that's the mix of DNA and proteins in the nucleus, it has this really unique look. It's speckled with little dark and light spots. The description is just perfect. It really looks like somebody sprinkled a little salt and pepper inside each nucleus. But the real giveaway, the thing that screams medullary carcinoma, is amyloid. This is this weird abnormal protein that gets deposited in the stroma. That's the supportive tissue around the cancer cells. And this amyloid, well, it has a hidden, almost magical property.
So check this out. When a pathologist uses a special polarizing filter on their microscope, these amyloid deposits suddenly light up with this specific, really striking apple green glow. It's this beautiful, vivid confirmation of the diagnosis. You just can't miss it.
And that brings us to our final suspect. And honestly, this one is the most formidable of them all, anaplastic carcinoma. This is the most aggressive, the most rapidly growing, and frankly, the most dangerous of all the thyroid cancers. It usually shows up in the elderly, and it presents as this huge tumor that's often already invading nearby things like the trachea and esophagus. Microscopically, the cells are just a chaotic mess. You see a mix of bizarre small cells, spindle-shaped cells, and even giant cells. Widespread cell death, or necrosis, is also super common. It's really just a microscopic picture of pure, unchecked aggression.
So after all that work, after carefully looking at all the clues and identifying the suspect, what's the final verdict? Well, this is the part where pathology connects directly back to the patient's future, because each diagnosis carries a very, very different outlook. This chart really sums it up perfectly. Papillary carcinoma, our most common suspect, has the lowest aggressiveness and generally an excellent prognosis. Follicular and medullary, they're kind of in the middle, but anaplastic carcinoma, it's all alone at the top, with the absolute highest level of aggressiveness and a very poor prognosis. The identity found under that microscope directly translates to the clinical outcome. You know, a pathologist's work is really a form of storytelling. They're piecing together all these tiny cellular clues to reveal a profound truth about a person's health. And as our tools get more and more powerful, you just have to wonder, what does the next chapter of cancer detection even look like? Are we going to rely less on the microscope and more on super precise genetic clues? That's the question that's driving the whole future of this field.